Minimal APIs are great until they aren't. You start with a few endpoints, everything lives in Program.cs, and it feels clean and simple. But after a few weeks in production, that same file turns into a mess. Dozens of endpoints, mixed concerns, and no structure at all. In this video, I'll show you how to keep the minimal API approach but structure your project properly using Carter library without controllers and without over-engineering. Let me show you what this actually looks like in real production code. So here is a Program.cs file with orders, with customers, and we have health checks and version endpoints. For database, we are using in-memory database. I have already prepared Postman collections where you can try if everything works fine. I will create an order. I will use this ID to get the same order here. Everything is okay. For health check, you can see healthy and version is 1.00. So nothing here is technically wrong. But the problem here is maintainability. The question that arises here is where do I add a validation? Where does authorization go? How do new developers find anything here? If you have, for example, 20, 30, 40, 50 endpoints, which is real world case, this is usually the point at which teams give up on minimal APIs and revert to controllers. But that's not necessary. And what interesting here is that this problem usually isn't about missing frameworks. It's about how we think about structure and responsibilities in our code. And this is something I have been thinking a lot about lately. Clean code almost always comes from clear thinking, not just knowing libraries or syntax. That's why I personally like learning platforms that focus on how you reason, not just what you type. Brilliant.org is a good example of that. One course I really like there is Computer Science Fundamentals, where you build intuition around algorithms, abstraction, and problem decomposition through interactive challenges. Instead of passively watching videos, you work through problems that force you to think, experiment, and build intuition, which helps a lot with system design, architecture decisions, and even API structure. If you want to try it out, head to brilliant.org/thecodeman, or you can also scan the QR code on screen. You'll get a 30 days free trial and 20% off an annual premium subscription, which gives you unlimited daily access to all courses. We can improve this with Carter library. Carter library is a small library built on top of minimal APIs. It doesn't introduce MVC, attributes, or some magic. It introduced one simple concept. A module is just a place where you group related endpoints together. So let me show you how to transform this Program.cs file in nice Carter modules. First thing we are going to do here is to install NuGet package named Carter. We will use late stable version. Okay, that's done. We will go back to Program.cs. The first step is trivial. We register Carter and map it. So we need to register Carter, builder, services, add Carter, and we need to map it in our application. App map Carter, and immediately Program.cs goes back to what it should be, configuration only. Now let's move all of those endpoints to Carter modules. In order to do that, I'm going to create a new folder and name it features, and this will look like something similar to vertical slices architecture. Into features, I'm going to create another 3 folders for orders, customers, and health. Okay, let's start with orders module. I'm going to create a new class named orders module, and this is going to be sealed class, and this module needs to implement iCarter module comes from Carter library. If I'm going to implement this interface, I will get add routes method. Inside add routes, we define the same routes as before, just not in Program.cs. So for orders, we have get a certain order, create an order, and delete a certain order. So we have three endpoints. The first one, map get orders with the past ID, and let's call the method get by ID. I'm going to generate this method. I will implement it later. I need map post for orders, and I'm going to call create method. And the last one, I'm going to map delete endpoint for orders for certain ID, and I will call delete method. Here we can see that endpoint handlers orchestrate the request and delegate real work to services. So let's implement one of those methods. Let's make it static, and for get by ID, I'm going to accept GUID ID. I need order service. Let's name it order service, and I need cancellation token. As you can see, I'm using the newest version of Visual Studio, and now it generates for me the complete code I need for this implementation. So I will get a new order for my order service. My order service is nothing more than just finding order with past ID from DB, which is in memory database currently, and I'm going to return that order. If order is not found, I'm going to return not found. So in order to make it work, I'm going to return iTask of iResult. Okay, I don't want to bother you with implementation the remaining two methods. I will implement it really quickly. And create and delete methods are implemented in the same way. I will go back to Program.cs file, and now everything about orders I can delete. So in that case, if I run this application and go back to Postman, and if I try to add new order as before, you can see new order has been added. I will try to get the same order. Everything is fine, that works. And let's delete that order. Is deleted. We'll try to do it again. I will get 404 not found. Perfect. I'm going to do the same thing for customers because each feature gets its own module. So let's do customers module. It's not modules, it's module, and let's implement that interface. I will do the same thing as for orders, and you will get it in 2 milliseconds. Customer module is done. We have only two endpoints. One is to get customer with ID, and another one is to create customer. Again, I can go back to Program.cs and I can remove those two endpoints for customers. Let's try with customers. If everything is okay, I'm going to the Postman. Let's go to create a new customer. Let's say I want to create customer with the name Stefan. It's created. I have an ID. Let's get back that customer, and that customer exists. Perfect. If you take a look on Program.cs, at this point looks really nice. And let's quickly do the same thing for health checks module. So we did the same for health module, and finally I can delete all of this. As I told before, immediately Program.cs file goes back to what it should be, configuration only, no endpoints, no routing logic, just composition. And if you add a new feature tomorrow, you don't touch Program.cs, you add a new module. For that module, if you need some services, you are going to just register those services. Even small endpoints like health and version checks get their own place. No more random endpoints at the bottom of the file. This is where Carter really shines. On the other hand, a feature-based folder structure makes the project easy to navigate, especially as the team grows. So when a new developer joins, they immediately know where to look. So now compare this to what we started with. The API is still minimal, the performance is the same, but the structure is completely different and scalable. One thing I like to add here is to group all the things into features. For example, create order request, I would put it into orders, and also services. Let's say for the order service, I would like to put it into order, and abstraction for order service, I would put it to the order. Of course, if this file will grow from time to time, and if I have more requests, if I have more services for this particular feature, I would group it into folders for requests and services separately. At this point, a very common question comes up. This looks clean, but what about, for example, validation? Where do I validate requests when I'm not using controllers? The good news is validation fits very naturally into this setup. And notice a few important things here. Let me show you how to add validation. In orders feature folder, I'm going to create a new class and I will name it create order request validator because we are validating request. This is going to implement abstract validator from Fluent validation for class create order request. I'm going to create constructor and I'm going to add two rules. The first one, let's do it for the product name. I will use Visual Studio feature. Product name should not be empty with message product name is required and maximum length is 100 letters for product name with a specific message. I'm going to add a rule for the price that should be greater than 0. Now I need to register this validator in Program.cs file. We have registered that validator. Now in orders module for creating a new order, I can use it by adding validator interface of create order request. I will have validation results where I'm going to validate request, and if validation result is not valid, I'm going to return messages why this validation result is not valid. Otherwise, I'm going to create order since everything is valid. And if you want quickly to check this one, let's go back to Postman. Let's try to add order. Let's say that we have product name course, but price is 0. I will send that request and I will get one or more validation errors occurred. Price must be greater than 0, which means that validation in this case works perfectly. Notice a few important things here. First, the validator is injected just like any other dependency. Second, validation happens before we touch the service or database, which is normal. And third, the flow is completely explicit. When validation fails, we immediately return a proper validation response. This works beautifully with minimal APIs because there is no hidden behavior. You can read the endpoint and understand everything it does. And if you want to go further, you can easily wrap up this into an endpoint filter or a small helper. But I usually start with this explicit approach because it's simple and very readable. Of course, this complete class, you can put it directly into orders module, but I like to make it separately. So when to use Carter? Carter is not mandatory. If you have 3 endpoints and a small proof of concept, you don't need it, honestly. But for production APIs, microservices, CQRS, or vertical slices architectures, it's one of the cleanest way to structure APIs. If you like minimal APIs, but hate messy Program.cs files, give Culture a try. It's completely free. I have linked the full article with code examples below. Also, the complete source code for this example you can find below in the description. And if you want a follow-up video, Carter with CQRS, validation, and clean result types, let me know in the comments. If you like this video, hit that like button and subscribe to my channel for more content. See you in the next video. Dream big.